So welcome to this presentation. I'm Jens. I wrote this paper together with Tobias Schraner and Daniel Hall, my professor. It was also done in collaboration with construction professionals of the Building Smart chapter Switzerland. So in brief, our motivation of this paper was that high quality data sets with consistent data updates are very valuable for construction projects, real estate, buildings, but it's often an issue to get these high quality data sets at the end of a project. This is not only related to technical issues, but also often to the many stakeholders and organizations that are involved in this process, and also that the process evolves over time. So data needs to be updated if you know more and more about certain things, as with this door example here. So our hypothesis is that blockchain can be a very useful tool in the data collection process to ensure these high quality data sets. And high quality data sets we consider to be complete data sets, so relevant information needs to be stored and updated. They need to be correct, so they're useful, and also they need to be structured in a way that they can be retrieved and found later on. To understand a bit better why blockchain is a suited tool for this, let's briefly discuss what blockchain is. So blockchain can be seen as a system that records transactions over time as they happen. Very similar to accounting systems nowadays, where you record transactions and you can see the current state of the system by looking at the past transactions. Blockchain does this in a very, very special way, so that you have some additional benefits using that system. So transactions are gathered over time and put into blocks. The blocks are attached to the previous block, and when more transactions arrive, this process repeats and repeats, which in the end forms a chain, which is hence the name blockchain. So this gives us a very transparent record of transactions over time. You know exactly when which transaction happened. And because the links between the blocks are based on cryptography, they're very hard to break, which ensures some form of immutability. So once written to the ledger, to the blockchain, the transactions are very hard to remove or alter the transactions. This runs, for example, on my computer, and an essential feature of blockchain systems is that it's a distributed network of computers where all run the same copy of the blockchain, so they can look what the others are doing and keep each other in check. So trust is very important when you deal with sensible systems like data storage or data collection processes, and transparency and immutability can lead to trust in the system. But also the P2P network, transactions are happening directly peer-to-peer, ensures that there is no intermediary that actually can influence this process. And it's also considered quite efficient to have these transactions peer-to-peer without intermediation. In addition, you could look at this network of computers as one single world computer, where you can also deploy code. These code protocols are called smart contracts. So with these smart contracts, you can code logic that somehow interacts with these transactions. So you can code workflow processes, but you could also code incentive systems, in the sense that you can create money with smart contracts and blockchain. And this money can be used to incentivize the actor. We call these tokens or coins, depending on the way they're coded. So the methodology we used, as I said, it was done together with construction professionals. We looked together at the design bid build process in the Swiss industry for a typical construction project, and we tried to find out how we can incorporate blockchain in this process. We also coded a simple smart contract prototype for the Ethereum blockchain. And in the end, we evaluated benefits and challenges of this system and also impact on stakeholders and together with these construction professionals. So the whole blockchain prototype was based on this exemplary workflow It's a simplified workflow, less actors, less working steps than a real construction project. But in the end, the goal was to just show that this would be feasible and suggest some ways on how we could do that. So we code smart contract functions for each of these workflow steps to request data of the involved stakeholders, or also request certain actions related to these working steps. The way that we can control that the order of these functions, that you just can't call that you can't call a later function first, is done with state variables. So once you want to call a function, it checks whether the state variable is the correct state, and only if this is true, it allows the execution. We coded that with Remix, which is an online IDE web-based tool where you can code smart contracts in Solidity and then deploy it to a virtual machine that imitates the Ethereum blockchain. This allows to interact with the transactions that you coded, that you can see if they work, can write out data, retrieve data, and you wish we were able to show how this could work. So key takeaways. Overall, it was considered promising that the strict and formalized smart contract processes help with the aspects of completeness and structure, in the sense that structure can be given by the smart contract functions. They only allow for to save it in a certain ways, or they even take care of saving or of saving the data, and complete in the sense that people are forced to input something so that they can proceed to the next step. You could also incentivize that with payments that are attached to these transactions, so they're incentivized to provide this data. These incentive systems through these tokens were also seen as very promising for the correctness aspect, because to make sure that people don't just submit some data, but actually correct and useful data, you could employ certain incentive systems that check whether the data was correct, and if yes, the tokens get sent to the one that gave the data, and this can be then used for certain things. This can be monetary, so they have a monetary incentive, but you can also code non-monetary incentives. For example, you can give them some reputation tokens that they can use later on also in the system. We are still in the process of exploring different possibilities for these incentive systems. Overall, the system was considered very promising, and it's feasible to do something like this, but also very challenging. There is, and at this point, I refer to the paper where we noted some of these challenges. I went very fast through what blockchain actually is, how it can be used in construction, crypto economic incentive systems for construction, and other ways to use these incentive systems and blockchain processes in construction. We have other papers. Encourage you to look at them if you're interested, and or ask questions later on. With that, I'm finished. Thank you for your attention.